Hello, everyone. 1, 2, 3. Mic is working. Everything's fine. So thank you all for being here today, even though there's almost the last session of the event. I'm happy to hear you, to see you here in my session. So just for clarification, who are you guys, from you guys are a more technical person? Could you please raise your hand? Excellent, excellent. And more business? Okay, so to be honest, I am somewhere in between. I was a technical guy for the last 10 years, but more focused on business right now, so I wouldn't open any new news stories about WebGPU, but I want to tell you a bit more about how it works, why we use it, and what it's all about. So start with me. My name is Andrey. I'm working in XR industry almost 10 years. Many of you maybe heard about the projects I was participating in, but for a long time ago, I was working in Microsoft and was responsible for launching HoloLens, launching first virtual reality applications and games on, you know, that platform, Windows Phone, Windows 8, the old-fashioned style things that are not with us anymore. So right now, I'm a founder of Metaplan. The idea of the product is that we are trying to become the new WordPress for Web3 and the 3D internet of the future. I was long time working as the co-founder of XR development agency, so I hear a lot of pain from my team and my customers about providing some solutions for being able to host many people in one environment, to make it easy, make it affordable, and like Metaplan is one of the ideas that we're trying to approach this way. So you could take a picture of my email in case you want to reach me out after the session, or anyway, I have that, the email in the last slide. So what it's all about? Metaplan, we are trying to develop the Metaplan as like a brick-like platform that supports any environment, that could be extended by different modules, that could use your own authorization system, your specific or proprietary or any custom avatar system. So anything you could imagine, you could do inside our platform instead of using the public platforms that have their own things that you couldn't avoid. So we are trying to provide a solution for any businesses that could help to speak with their audience in Metaverse space. So it's more about building a website, but 3D website with interactive environment and collaborative environment to speak with any clients, any customers, any partners, or inside the company altogether. So it's more about, so when people ask me what is Metaplan all about, I'm trying to answer something like it's the same as the website today. Metaplan would be in 10 years after. And it's very hard to say how people use the websites. They use it any way it's possible. And we are trying to become the open platform for everyone. We use it for real estate, we use it for retail stores, we use it even for regular collaborative system. We host our own meetings in Metaplan. So that's a challenge, because if you have to fit all these needs of the wide audience, it's very complicated to develop the thing properly. So we're trying our best. I've seen here lots of competitors of ours on exhibition. They are doing pretty same things. They have similar challenges. And one of that is the graphics. So that's why I was trying to understand how the WebGPU would affect our business, how it would affect the quality of what we're doing, and comparing to Unity, Unreal Engine, and other engines that have their rich clients, how we could try to develop and distribute the good quality graphics on the web. So to speak about that first, like I need to start why we start with web, because I was mentioning that I'm developed XR projects for a long time ago, and if we are trying to speak with the marketing guys or with business guys, the first thing that we are discussing after starting conversation about the project, should we do the app or not? Because right now, if you know about AR and VR, everyone trying to avoid applications if we speak about marketing communication, because their audience are there and they're trying to go this through awareness channel, attract some interest, and then if they're ready to try, we have a huge funnel gap because they need to install the app. They need to have a device, they need to install application on their mobile phone, they need to install it on a laptop or whatever. And that loses like 70% of the audience. That's a huge problem. That's why you see the rise and shine of WebAR, WebXR technologies right now everywhere. And like companies like ours are trying to be as efficient as standalone applications, but trying to fit it into the WebGL paradigm and trying to make it work in the browser the same way. It's a challenge, to be honest. I couldn't say that we are really, really great at that, but we are still like trying our best. So first metric that we're trying to discuss every time with the businesses is the time to experience. So when and how people from your outreach, from the business outreach, how long it take for them to join the experience. So if it's QR code or it's NFC or whatever, then they install the app, then they're trying to open it, then they need to authorize, then they need, and all that needs that need to be fulfilled. And right now we're trying to fix that funnel on every stage to increase conversion, because by providing the links, we could disable authorization, we could support many different browsers, we could use applications, we could use like just browser experience, we could work on any device with different frame rates, so we adopt the quality of graphics. And that's the challenge also. We decided to use Three.js. I'll tell you a bit later why. And in case we have a modular platform, we could change the Three.js renderer for Babylon or any other platform like in 2 weeks in case we really need it. And we're still thinking about that every day. So what's the difference between right now available quality of Three.js and Babylon.js? So I couldn't say that it's technically like really ideal comparison, because I am not a technical person, but we needed to make this decision, and we were trying to weigh the importance of different things that was in the beginning. So Babylon.js is more about, I personally know the guys who developed Babylon in Microsoft during my experience working there. And it's more about games, it's more about easy and fluid experiences, it's more about easy onboarding, it's about doing something right now and there. But unfortunately, the quality of graphics is a bit lower, but it's a bit faster in the rendering capabilities. So we were trying to evaluate what we need more, speed or quality. And after we decided that if we have smartphones like Apple with a chip with M1 chips with A12 and more and later chips, the commodity of the devices right now is much faster than it was before. So aiming on the speed would probably help us to reach the 30% of audience of low-end devices that would probably not be our main clients. So we decided to go with graphics, but then appeared that WebGPU require a bit more assistance from the Three.js team than they have now. Unfortunately, right now, you see I have a picture of the quality of rendering of the same 3D model. I'm not sure that it's really a true comparison, but like I got it from the internet where I'm trying to understand what's the difference. But all that we tried to achieve inside comparing the renderers, we found that Babylon.js have a bit more blurry picture in terms of render, but it's like up to 4 times faster. I think it's about upscaling or some kind of upscaling inside of the engine. We don't dig deeper, but that was easy decision. In case we could switch, we would try with Three.js, and then in case we needed, we could switch further. So right now, Babylon have a full support of WebGPU. I will mention that later. But to speak about WebGPU, I need to start WebGL. Who is aware about WebGL like in details? Nice. 1/3 of the tech guys here in the audience. So WebGL right now is a standard for web 3D graphics everywhere. So nobody even think about something else. It's supported by any browser, any platform, on any device. So it's easy as is. And back to 2015, I was presenting on stage at Unite Europe in Amsterdam, where Unity was announcing the support of WebGL 2 with their engine and showcasing demos. The quality was a bit poor, and unfortunately, we're developing on Unity on my other projects too, and unfortunately, the quality is still not great. So we will see. I hope that WebGPU will change that, but even right now, WebGL have its limitations. So lots of things could be changed. Then the main problem is the OpenGL that's it's based on. But it's still a standard. Everyone uses it. It have lots of different examples to use, and probably many of you seen them and use them in your work. So what is WebGPU in general? In general, WebGPU is the more efficient way to say, like, we have 3D in the browser. And it's developed by big guys on V3EU Alliance with involvement of Microsoft, Google, Apple, and all big tech companies, because they really need 3D to be fluent and fast in the browser. So the whole idea is about to make it as high quality as it on any other device and any other proprietary solution or any other platform engine. So it uses, as a sub-level of drivers, it uses DirectX, Vulkan, and Metal, and works as API, low-level API on top of them. So I have a comparison on the next slide. So it finally appeared as a public release on Chrome 113 this January. It's still like work in progress for Safari, for Edge, and for Firefox, but it's in Chromium already, so there are not so many months left, I hope, that it will be available. So I've seen that Apple is already showcasing the WebGPU demos on their WWDC, so we're still pretty close, in including the stories that they are launching the Vision Pro. The headset would be also compatible with WebGPU, so all WebXR experiences that are developed with WebGPU now, next year would be supported on Vision Pro too. That's really, really valuable for us because we also target the audience of the Visual Pro users. So what about WebGPU versus WebGL? First of all, to understand for all of you, so WebGPU is not about like making things brighter and shinier. You couldn't just switch the renderer and the API and to make it fluently work and easy. Here you could see the comparison here. So we have our application, then we have different layers. It's WebGL or WebGPU. It works in all browsers. Here, of course, right now, all browsers, but here we have still only Chrome. Then we have a low-level access to the drivers. And drivers we have here only OpenGL, who could proxy the request to the video card through all these three guys. But here on WebGPU, we have a level of abstractions that could utilize around 90% of the capacity and capabilities of the software level that's available on any platform. So it's DirectX for Windows, it's Metal for Apple ecosystem, and it's Vulkan for Android devices. Here, of course, we have one more level of physical GPU, but I didn't paint it here. The problem is that when we started to trying to switch to the WebGPU, we understood that we could use more. We could use more of the graphics inside the scene, but it automatically don't make scene more shiny and more like we haven't got better quality at all. So we need to do it a bit more gently. So we could add more lights. We could use some different interesting things like GPU upscaling. We could use instancing. We could use different stories like compute shaders that was unavailable on WebGL, but it still like requires lots of effort and lots of work to make your scene in 3D in a browser better than it was in WebGL. So right now, many of our competitors and partners still not decided whether they want to go with WebGPU or not. We are thinking that we could rely on the technology when it would be widely adopted, but right now we are competing with the big guys who do metaverses with Unity and with Unreal Engine with pixel streaming. It's tough competition because they have a better picture quality, but we have a better flexibility and we have more compatible devices available. So what about, in general, support of WebGPU? It works with Babylon.js as Scratch because the guys from Microsoft done a lot of job to make it happen. So you almost need nothing to do with your existing WebGL renderer in Babylon.js to switch it to WebGPU. Play Canvas and TensorFlow are supported partially. Three.js is still on the go. We have some issues, but like it's, I think, about 30 or 40% of the render capabilities are already there. We're still waiting for the team, the open source team who developed Three.js to fulfill all our needs, but we're starting to do that by ourselves a bit earlier to be ready for the final release. Of course, we're speaking about gaming engines. So Unity, Unreal, and Godot, they have different level of support. They all working on that, but Unreal Engine decided that they would stick better to their pixel streaming because that's their strategy with lots of different rich experiences that they have because they require more compute power and they want to provide better quality graphics streamed from the cloud instead of being hosted on the device itself. So lots of demos available for any of these platforms. You could probably, most of you already checked them, but they are still there. You could try and see how it evolves month by month because in the reality, that's really differs when you see a demo like a half year ago and now. They all evolve. This is kind of a demo that we tried to reproduce. We've seen this kind of scene in the Three.js demo, so this is our engine. This is a render without the shadows. It's very limited, but like we're still trying to work with it a bit. So this is 60 FPS on 3070 GTX. So there are lots of lights flying around, but there are no shadows because even with the shadows, the complexity of the scene increases dramatically. So this is one of the options that we're trying right now. We have a different scene when we're using the lights because another way to showcase the WebGPU is WebGPU instancing. So the default demo for Babylon.js is like you're having the low poly 3, and you just multiply it by 500, seeing how WebGL stacks on the frame rate, and WebGPU works fine because of GPU instancing. That's one of the simplest demo. You could take a photo of this link if you want to see the demo in real time, because we have that links on our platform too for you to share. But like it's very limited and complicated to showcase because like on my laptop without separate GPU, it's even for WebGPU, it's about like a 5 frames per second. Not really good result that we expected to reach, but the idea of the scene that is not optimized and we're trying to like put hardware under stress. That's it. Mostly about all that I wanted to share with you, except one thing. WebGPU is also a level of abstraction of GPU, and right now everyone is trying to do something with AI. So WebGPU could be used also for hosting LLM models, and if in case you want to extend your presence in Metaverse or provide some extra capabilities, you could host the AI neural networks inside the browser, like inside of your experience, to power up your NPCs with a real lifestyle communication, like a natural language behavior. And also, you could even try to Stable Diffusion. Unfortunately, I have a link here, but you probably could Google it. It would be easier to find. So someone already put the Stable Diffusion there on top of WebGPU, so you could host it anywhere in the browser. If you have a powerful GPU, you could just go to the website and that's it. No need to host anything on top of that. So that's probably it. I have 2 minutes left for your questions if you have any.
Thank you very much, Andrey, for this presentation and the insights. Are there any questions from the audience? Please raise your hand and I'll come with the microphone. Don't
Almost
be
no questions.
shy.
Anyway, I have my CTO couldn't come to this session today, so if you have any technical questions, you could nail me here.
Don't be shy.
Yeah.
Anyone
We have a question there.
Yeah? Okay. Thank you.
So have you ever considered using Bevy engine as well? I mean, it compiles to WebAssembly, I think, and can use WebGPU, at least in the latest version.
What engine? So we could do WebAssembly, but like for not for all the things in our engine, but we're considering this too. But I misheard the first part of the engine.
The engine's name is Bevy.
No, I never heard about it, unfortunately. But like, yeah, WebAssembly is one of the things that we could do to lower footprint and make it like faster. But right now, it's totally enough for everyone to use the WebGPU from scratch. If we want to make it faster, we can switch to Babylon. It's easier for us. But like maybe in a half a year or a year, when WebGPU will be widely supported, there would be a rise of different engines that could be ported from anywhere to web. And they would be very niche to use for any general purposes, maybe for us too.
Thank you. Anyone else?
Any more questions, please?
No? No, there. Thank you.
Can resist. I'm a visual learner. Is there any, what's the story with your logo and the WebGPU on? Purely accidental?
It's low poly logo of like Metaplan, nothing specific.
The WebGPU one's at the same flip.
Honestly, I never thought about that. Yeah, kind of. Probably they could sue us. Interesting discovery.
Anyone else up for an interesting discovery? Any more questions? No? Well, thank you very much, Andrey. Thank you for this.
Thanks all for coming.
Thank you.